It's an honor to be here for this kickoff lecture. It's a very exciting series, and I hope I'm up to the task of really sort of starting out in an exciting way. Now, right when I began preparing this talk, I was given a new smartphone. And so a day looked like this. I was preparing the talk. I was downloading apps. I was discovering and playing new computer games. And then, all of a sudden, these tasks merged in my mind. And I asked myself the question, what would the demography of the 7 billion computer game look like? Now, I've worked quite a bit on this. And although I'm not nearly done, I'd like to share my ideas with you on this, what this game might look like. Now, the first problem with any game is that you need a great visual icon. You need something or other which sort of stands out and immediately brings the nature of the game to the viewer. So I began looking for icons. And of course, I found the bomb, which was an early one. And then, of course, there's the explosion. And then, of course, there's the earthquake, based on Diane Mikunovich's book called Birthquake. And there's Gray Dawn, which on the title page says the major economies of the world are on a collision course towards a huge, as yet unseen iceberg, global aging. I got a picture here of the Titanic steaming toward a head of iceberg lettuce. I know it's not, it's not quite as scary as what Peterson had in mind, but you sort of get the picture here. And there's the silver tsunami. I don't know where that phrase originated, actually, but there was an article in the Vancouver Sun with that title not too long ago. And this is a picture of the actual tsunami in Japan. And then we have Patrick Buchanan's book, The Death of the West, so we have yet another image of death. And you see immediately, as a sort of game producer, I have a problem. I sort of, all the good catastrophe images have been taken. I wasn't really creative enough to produce a new catastrophe. And so, since I'm not so good at these visual things, I thought of at least something temporary, which I might use. And so I thought maybe I'd have this symbol, which is sort of the B crossed out, and it would be my no bombast guarantee. And the no bombast guarantee is that this game is going to be as realistic as possible. It's going to be based on information and not on speculation. Now I have a confession to make. As you learned in the introduction, some of the things I do has to do with forecasting. And when people learn about this, the image that they have in their mind is always that image on the left, which is what I do in my professional life as I stare at a crystal ball and come out with numbers of one sort or another. But it's a bit more scientific than that. Now, every now and then, I go to a cocktail party, and when I've had a bit too many drinks, I actually admit to people what I do. And I could tell you with 90% certainty that that will not be a good thing. And the reason is that people will say to me, almost always, think back 50 years, think back 100 years. Who would have predicted 100 years ago that we would have smartphones, that we would have the internet, and we would have Angry Birds apps on our smartphones? But this sort of misses the point, really, because although we didn't have tablet computers 50 years ago, and there are many things that were hard to predict, we did have a birth rate 50 years ago. And we did have a death rate 50 years ago. And we have a birth rate 100 years ago, and 1,000 years ago, and 10,000 years ago. It's not that the birth rate has to be invented or the death rate. So long as there are people on this earth, there will be birth rates and death rates. Our job as forecasters is not to forecast some new innovation, but to make a guess as what the numbers are going to be like. Now, population, relatively speaking, relative to things like the economy, is comparatively easy to forecast over long periods. And the reason for that is the structure of population change is relatively easy. Populations change only because of births, deaths, and migration, nothing else. No new form of population change will ever be invented. And because many people who will be alive in the next half century are already born. For example, if you look at the people who will be alive on the planet in 2050, more than half of them were already alive today. So it's a little bit easier than asking what kind of apps will be on the cell phones or the smartphones of 2050. We have a lot of information. Now, this game is going to be based on the best forecasts that are out there. And there are two that compete, really. There's the UN forecasts, which are made every 2 years. And the latest ones are the ones that are called the 2010 forecasts. They came out in 2011. In a few months, there will be another set from the UN. And there's the set of forecasts that I'm associated with. That's produced by a group of us at the International Institute for Applied Systems Analysis in a suburb of Vienna. Of course, ours are better, but we're not going to go into that now. Now, it's important when you think about this game to understand what a forecast means. A forecast doesn't tell you what will happen. That's a really dumb game, right? The same thing happens all the time. Forecasts tell us what is the average result if the players behave with the same skill and intelligence and wit and inventiveness as people have had in the past. So a forecast only tells us what will happen if people work as hard in the future and invent things just as they did in the past. A forecast doesn't tell us what will happen if nothing changes. Now, of course, the game will have some avatars. And there will be some people walking around in this game. And if you get a chance to play it, you may find these two characters. They're Wolfgang Lutz and Sergei Sherbov, who share the the responsibility with me of producing some of the forecasts that you'll see. I haven't decided whether to endow any of these avatars with special powers, but if I did, I would certainly endow Wolfgang. Wolfgang has made Vienna into a center of demographic research in the world. So here's the setting. There's a setting of the game, and this is the setting of the world. The world's population is now at about 7 billion, and it's expected to go up to about 9 billion by 2050. And in this, we in the UN agree, which is, as you might think, because most of the people who are going to be alive at that time are already alive. Where we disagree some is what's going to happen after 2050. But broadly speaking, what's going to happen after 2050 is that the world's population is going to stop growing. Maybe it will grow a little bit, maybe it will grow a little bit and then shrink. But around 2050, we will enter a period of virtual zero population growth. So let me put some numbers on this thing that I told you, because many players of the game won't realize that by 2050, world's population growth will be over. According to the UN, the annual rate of population growth of the world between 2050 and 2100 is going to be 17/100% per year. We think the 17/100% a year is a bit high. We actually think that the world's population will be smaller in 2100 than it was in 2050, and the average rate of shrinkage will be 5/100% a year. Now, the difference between 17/100% and -5/100% is pretty small. These are the difference between two numbers that are close to zero. So although we don't know that the population of the world is exactly going to stop, but roughly speaking, in that half century, we will enter a new era of zero population growth, which means that we have about 4 decades of population growth left. That's it. And then it ends, which is, I think, rather remarkable. So here is the picture of the 2 phases of our population growth during the century. The more rapid phase between 2010 and 2050, when the rate of population growth in the world is about 0.7% per year. And then you see from 2050 to 2100 how it decreases. They're 2 very distinctly different phases. And here is the same graph instead of in growth rates in terms of numbers. And you see the same sort of thing, 2 very distinct phases where the growth of the world's population in 2050 to 2100 is either small or negative. Now, any good game needs an interesting starting point. And this is a good graph to actually think about, this starting point. This graph shows you the number of years it takes to add 1 billion people to the world's population. Now, it took over 100,000 years to get to 1 billion in the first place. To get to the 2nd billion, that's the first line on the left of this graph, took a little over 120 years. To add the 3rd billion took about 30 years. And you see that the time it takes to add an additional billion was going down and down and down, which of course was quite scary. But you see that that curve is U-shaped, that it doesn't go down forever, but it turns around and starts going up. And if you squint at that, you see that when it starts going up is now at 7 billion. So I have an announcement for you today. Doesn't have to do with the game. Today is World Population Solstice Day, by which I mean today is the day in which the whole long history of mankind, where the addition of successive billions of people took fewer and fewer years, has come to an end today. And starting today, the addition of billion more people to the Earth's, to our population will take longer and longer and longer until finally population growth stops. Well, that's pretty exciting. Actually, I've never announced anything like this before. And if your grandchildren ask you, where were you on World Population Solstice Day? You will say you were there in Vancouver and you actually heard it announced. Now, World Population Solstice Day is not a once-in-a-lifetime thing. World Population Solstice Day is an event that occurs once in mankind's history. This is the day. Well, all right, so this is a no bombast talk, and this is going to be a no bombast game. So you know I don't really know it's today. It could have been yesterday. It could have been last year. Maybe it's next year. It's around now at 7 billion. And the UN announces various days, like this is the day of 7 billion, this is the day of 6 billion. They don't know either. So I don't know exactly that this is the World Population Solstice Day. But it's important for understanding where we are in the world and where we're going to mark these days. Something is happening now, right around now, that is a watershed in human population history, and we need to commemorate it. So I am commemorating it right now on this day. So this symbol has yet another meaning. It means today is World Population Solstice Day, and today is the end of this era in human history which was with us from the beginning, where additional billions took ever shorter periods, and starting today, that's no longer true. Okay, so let's go back to the game for the moment. We have 2 periods in this game. The game is going to start today, which is a very meaningful day, which is the World Population Solstice Day, and it will go in the first phase to the world population plateau, where the world's population will remain more or less stable for fairly long periods of time. So we have 2 phases of population change, a more rapid phase of growth between now and 2050, and zero growth essentially thereafter. Now, I told you that there are really 2 phases that we should expect for our population story for this century. There is a transition stage and a plateau stage. But this doesn't mean that everything has a transition stage and a plateau stage. And here is the graph of our population meaning the population of what the UN calls the more developed countries. And this graph shows that we are already at the plateau in terms of the population of the world's more developed countries. There is no more population growth for us in the aggregate. It is done. Okay? That's very important when we want to think about sort of the ecological consequences of population growth. The richer countries have no more population growth in the future. Now, in order to play the game, people should know something more about the details of what goes on in terms of population change. And one of the most important things is fertility. So how many children women have? And when you think about fertility, there is a magic number which you really want to think about. That magic number is 1. When women of reproductive age produce an average of 1 daughter who will replace them in the future population, then that is replacement level fertility. Every 100 women produce 100 daughters who will replace them as reproductive age women in the next generation. And that's something we shoot for. That is something which would bring pretty much stability to the world's population. Not exactly, because there's some extra population growth which is going to happen because of increased life expectancy, but that will be very close. So think in your mind of what do you think this number is for the world today? Is it 2? Does the average woman have 2 daughters who will replace herself? Is it half? Well, the answer is, in today's world, the average woman of reproductive age produces 1.06 daughters who will replace her around 30 years later as reproductive age women. That's not a lot above 1. That's actually quite close. We are quite close to having replacement level fertility in the world as a whole. Now, the UN tells us that this is going to happen. We'll get down to 1, and the UN forecasts, in around 25 years. Now, we think it will be a little bit shorter, maybe around 15 years, but you could take the average and put it this way. In 2 decades from now, roughly, plus or minus a little bit, above replacement fertility, which has been a characteristic of humans from the beginning of time, will end. We only have about 2 decades more in this world of above replacement fertility. That's it. 2 decades more. That's not much, and that's pretty amazing. So here is the graph that the UN has of this, and you see that graph peaked around 1970 and is going down, and the UN has it very close to 1, starting basically now. We're at 1.06. Now, the big difference between our forecast and the UN forecast is we think this number actually will go down below 1. Now, what does this number look like for Canada? Well, Canada has had below replacement fertility since about 1970. Okay, so about 4 decades, almost half a century of below replacement fertility in Canada now. And the average Canadian woman of reproductive age produces only 0.8 of a daughter, okay, to replace her in the next generation. That's a shortfall of 20%. Every generation, Canadian women produce 20% fewer daughters than is required just to replace themselves. And of course, Canada's population grows because of immigration, not because of natural increase. That's a pretty substantial rate of non-reproduction, so to speak. Here is a few countries that I chose sort of semi-randomly. We have India, where we're now at about 11% above replacement. The UN says it will go to 1 around 2025. We agree pretty much with that. You can look at Iran. Iranian women have a shortfall of about 1/4, so 100 Iranian women only produce 74 daughters who will replace themselves in the next generation. But I want to call your attention to two countries in particular, Indonesia and Brazil, because I want to talk about them later. Both Indonesia and Brazil have below replacement fertility, which means women don't produce enough daughters just to replace themselves. Well, it's important to understand what goes on in terms of life expectancy. And here we have infant mortality rates. These are death rates of children, of 1,000 children in the first year of life. You notice for the more developed countries in 1950, that started out at about 60, which is 6%, and is now down to about 6. So the death rate of children in the more developed countries is 0.6% in the first year of life, which is really a miracle. In the least developed countries, it was 20% around 1950, 55, and is now down to about 8% and falling. These are well-known numbers. What's not so well known is this graph, which is the graph which got more demographers kicking themselves, I think, than any other graph in history, because it's so beautiful. And anybody with a high school education could have produced it, and it turned out that it was in an article in Science. Its scale of time is 1840 to 2000, and what is recorded here is the world champion life expectancy. So this is a country that has the highest life expectancy. And this is the graph for women. And you notice this graph is a remarkable straight line for 160 years. It's amazing, actually. And what everybody does when new data come out is they look to see whether it's continuing, and I could tell you this has continued upward in a straight line for another 10 years now. Now, what this tells us is that life expectancy doesn't appear to be reaching some kind of maximum. You see, if human life expectancy was getting towards some sort of maximum, this curve would be bending downwards and getting flatter and flatter instead of going up and up and up just in a straight line. So when we deal with the future, we're going to have to deal with a world with pretty amazingly long life expectancies. Now, it's very important when you think about the world to think not only in terms of numbers, but in terms of the capabilities of people. And there is an education revolution going on in the world. And my friends at the International Institute of Applied Systems Analysis have produced some new data reconstructing education distributions in the past and making forecasts for the future. This comes from a recent article in Science by Wolfgang Lutz and Samir K.C., and it basically is the population pyramid of China with education included. And you see by 2030, although it's hard to see, almost the entire adult population of China will have secondary education or above, which is pretty amazing. Here are two more avatars that you may see. These two guys are the people you want to talk to about education, Yan Gujan and Samir K.C., and maybe about some other things as well. Here is the world's population by education level. The time frame is 2000 to 2050, And there are 4 scenarios here, but I only want you to look at the far left scenario called GET, which is short for Global Education Transition. The bottom section is the number of people in the world's population 0 to 14 years of age. And look at that. That's not exploding. That's constant now. Between 2000 and 2050, the world will have no more children in 2050 than it has today. But what's exciting is what happens in those 2 upper groups, which are tertiary education and secondary education. And you see that the world's population of 2050 is going to be much, much more educated than it is today and than it was in the past. So that's basically the setting. But no computer game is fun without challenges. You must be able to slay the monsters, and you must be able to do the difficult stuff that makes playing the game fun and challenging. And the world has lots of challenges for us. It has lots of challenges that we need actually to work on in order to get through this transition period into the period of the world population plateau. Now, one thing which is often discussed is aging. And I want to talk about this in 2 different ways. First, I want to just say a few words about aging on a global level. Now, aging globally is actually not the problem. But what has happened is that demographers and economists and all sorts of people have used measures of aging which make it look much worse than it actually is going to be. And there's a reason for this, which is that the characteristics of people are changing. So you might ask, when do people get old? You know, when do they go from adult to senior citizen? When do you go to the movies, right, and pay a lower fare? And that often is age 65, right? And so we say somebody is old when they get to age 65. Well, 65-year-olds today are not the same as 65-year-olds who were 50 years ago. 65-year-olds today have longer life expectancies, are healthier, are cognitively sharper, have lower rates of disabilities. And 65-year-olds today are not like 65-year-olds are going to be 50 years from now. And so if we say that people get old just according to the number of birthdays they've had, that's not a very interesting measure. We want to know how people function. And when you do that, you get a different picture. So here is a graph from an article that Wolfgang Lutz and Sergei Sherboff and I published in Nature. And I want you to look just at the 2 bottom graphs for a moment. One is labeled Prop 60 plus. This is the proportion of the world's population who are 60 years of age and over. So this is, people get old at the age of 60. 60 was chosen because in Europe, people are considered incredibly old at 65. They should be retiring at 60, right? So here's a proportion, 60 and above. And you notice that that goes up pretty steeply. But there's another view of aging, one that we hold, which is that we ought not to say people are old according to the number of birthdays, but people are old according to how close they are to the end of their life. When they're close to the end, so we conceptualize this by saying people are old when they're in age groups where their remaining life expectancy, that's the RLE in that bottom graph, is 15 years or less. And you notice when you look at that, there's much, much less aging globally. And as a matter of fact, I'm going to talk more about this, but when you take into account the changing characteristics of people, the aging problem looks far less worrisome than if you don't. All right. Wrong graph. All right, here's another challenge. Are we going to be able to produce the food we need for this bigger population, this 9 billion that we're going to get by 2050? Or somehow are we going to starve? Well, one of my forecasting role models is this guy you see here, Jesse Ausubel. And Jesse is one of my role models because in 1982, I went to a seminar he gave about CO2 in the atmosphere, and he made forecasts that were exactly right. And I love forecasters who get it right. And so he is one of my role models. And he and two other people have come out with a new paper on how much farmland is going to be needed to feed the world's population. And this is going to be in a article forthcoming in the journal Population Development Review. And so you see the data here for the amount of farmland that was actually used between 1961 and 2009. And I put this statement on the graph that between 1960 and 2010, the world's population grew by about 4 billion people. And you see on that graph how much farmland was used to feed that extra 4 billion people. And it's not that much. Now, the forecasts that Jesse and his colleagues made for the future is that the amount of farmland that the world is going to need to feed itself is actually going to be less than the amount it uses today. It's an amazing forecast. Now, they're very serious. This is no bombast. This is quite serious. But it is a forecast which assumes that the same creativity, the same inventiveness that we had in the past will continue in the future. The same kinds of increases in yields which we've had in the past will be in the future. So this doesn't say if we don't do anything, the amount of farmland that we will need will go down. It just says if we are as incredibly inventive in the future as we have been in the past, we're not going to need any more land. As a matter of fact, we're going to need less land. And some substantial amount of land will actually be going back to nature. It's a serious forecast. And what tickled my, what got my attention about this forecast was that there's another similar forecast done in a completely different way with a completely different methodology that the UN does for the world's rural population. Now, you ought not to think that the world's rural population is exploding because the world population has just about reached its peak. And it will actually be pretty stable, and then by 2030 or so, will be going down. Now, the only thing that connects Jesse's forecast and the UN forecast is both of them take into account the fact that the world's population growth is slowing. And they come to more or less the same conclusion. Now, if you're playing this game, you have to be very inventive to get yields continually going up, as they have in the past. But there's nothing in the data that suggests that we are going to run out of farmland and die and starve to death. That doesn't seem to be in the cards necessarily. All right, how about getting through the transition period in terms of climate change? How big a challenge is that? Well, how much CO2 is safe in the atmosphere? And here is a quotation from another one of my heroes. This is an article, the lead author is James Hansen. James Hansen, you probably know, wrote a very famous article in Science in 1981 where he predicted almost exactly what we see now in terms of climate change. Another person who predicted correctly. And recently he and a bunch of co-authors wrote this: if humanity wishes to preserve a planet similar to that on which civilization developed and to which life on Earth is adapted, paleoclimate evidence and ongoing climate change suggests that CO2 will need to be reduced from its current 385 ppm, that's parts per million, to at most 350 ppm. The emphasis on 350 is mine. If the present overshoot of this target CO2 is not brief, there is a possibility of seeding irreversible catastrophic effects. Possibility of seeding irreversible catastrophic effects if we are above 350 for a long period of time. Well, this seems a reasonable statement to me. We all know that the ice in the Arctic is melting. There's less and less ice cover at the minimum every year. And this is basically a graph which tells something about what's happening to the Arctic sea ice, and it's getting less and less and less. And there are many other changes that we see in the world now. Okay. It's not as if we actually have to look hard for evidence of climate change at our current level. So it makes sense that 350 is something which might be safe. Well, where are we now? Well, this is the CO2 in the atmosphere measured at Mauna Loa in Hawaii, and you see it's going up and up and up. We don't see that humans have done anything to slow the advance of CO2 in the atmosphere. Now, there are two important concepts, of course, that we have to deal with when we talk about this, and which people need to know when they play this game. One is the concept of momentum. The atmosphere and the oceans are not in thermal equilibrium, which means that even without further increases in CO2, the Earth will continue to heat up. Even if CO2 in the atmosphere goes down, the Earth can continue to heat up because it takes quite a while for the oceans and the atmosphere to come into equilibrium. And there are a number of amplifying processes which, once we start, make the heating of the planet go more rapidly. The loss of ice is one of them. You probably know a whole bunch more. We could get into that a little bit if you want. So what's happening? Well, we're at 393 now, and these are the decadal changes. From 1963 to 72, it went up by 9.02 ppm. By 2003, 2012, the decadal increase was 20.74 parts per million. So you see that the increase in CO2 in the atmosphere is actually getting faster and faster and faster. So what are we going to do? Some people say that, well, if we can stabilize at 450, maybe we could avoid some problems. Well, at the current rate of increase, we're going to get to 450 in 2040. Okay? 2040 is 27 years from now. And we don't see any lessening in the growth of CO2 in the atmosphere. Moreover, there is nothing of any interesting magnitude we can do about the Earth's population between now and 2040, because most of the people who are going to be around in 2040 are already born. If we're going to deal with this issue of CO2, we can't deal with it as a population issue. It makes no sense. So I thought I would give you a little arithmetic, just to emphasize this point. In 2010, the average Canadian emitted 16.3 metric tons of carbon per capita. Now, how does this compare with some countries that have very rapid population growth? Well, there are countries like Burundi, Ethiopia, Niger, Somalia, where the average emissions are 1/10 of a metric ton per capita. So it is clear that 1 Canadian, in terms of CO2, is the equivalent of 163 Ethiopians. Now, the UN says that Canada might have 10 million more people by the time we get to 2050. So 10 million more people would emit as much as 1.63 billion Ethiopians. But there aren't 1.63 billion Ethiopians in the world, even if we were to drain that country of all its people. We cannot reduce the world's population in rapidly growing countries like Burundi, Burkina Faso, Ethiopia, as much as would be needed even to compensate for a growing Canada, let alone a growing United States. So that's a tough challenge. Now, there are in the world exploding populations. Population explosions are not over with. And I love this quote. This is a quote from a website called populationproblem.org. Okay, so how do we proceed? First, don't support any group that is impeding efforts to manage the human population, as if actually we could manage the human population. What a nonsensical concept. Do not await an apocalypse. We can control our own destiny. Okay. Apocalypse is sort of strong language for a world which is going to go to replacement level fertility in 20 years, where the average woman, even today, average woman of reproductive age today only has 1.06 children. But okay, some people believe we are on the verge of apocalypse. But there are exploding countries, and we have to deal with them somehow. Now, these are a few countries listed alphabetically. The first one is Angola. Angola has a projected population in 2050, which is 3 times its population today. 3 times. That's a population explosion. And there are 2 champs here, champion exploders in the world, and they are Niger and Malawi, whose populations are expected to be 3.3 times higher in 2050 than they are today. 3.3. It's astounding, actually. So let me tell you just a few words about Niger. Niger is in the Sahel region, just part of it is in the north parts in the Sahara Desert. As you go farther south, you get into an area which is semi-desert, and only as you go to the very south, as you have some regular water supply. It has one of the world's lowest literacy rates. Its population growth causes desertification because animals eat the plants which keep water in the soil. And the UN has an index called the Human Development Index, which supposedly indexes the well-being of people. And out of 187 countries, Niger is 186. So you have one of the poorest, least literate countries in the world having a population that's exploding. Now, what do you do in this case? You're playing a game. What do you do? Well, you might want to consider actually having some international aid for family planning. Now, here is data on international aid for various things having to do with population. And you see 3 bars. And the bottom bar is HIV. And the top bar, the green bar, is other reproductive health. And the middle bar is actually family planning. And this is all the money that the world donates to developing countries for family planning. And now I'd like you to look at 2004, or maybe 2003 or 2005, and look at that middle section. And you will notice that family planning expenditures, this money that the rich countries donate for family planning for poor countries, basically went to 0. We simply stopped caring about family planning. Those lines in 2004 are so close together you could barely see there's anything there. Now, 2008, there's a little bit, but that's really extremely tiny. The world spends very little on supporting family planning programs in developing countries, amazingly little. And one thing one might want to do about countries that have exploding populations is perhaps to spend a little more on this. And another policy, of course, is a policy that has to do with education. Educating women particularly helps bring down fertility and helps empower them. All these things that have to do with things like family planning and education are things which perhaps one ought to think about when one thinks about exploding populations. Now, there are shrinking populations. Now, the champ in terms of the world's fastest shrinking population is Moldova. Moldova is expected to lose 40% of its population between now and 2050. 40% of its population is an enormous amount of depopulation. Almost half your population vanishes between now and 2050. That's difficult to deal with. But I would like to draw your attention to a bigger country, which is Japan. Now, Japan is expected to lose 30% of its population. 1/3 of Japanese population is expected to vanish between now and 2050. A whole third of Japan, or at least the Japanese population, will be gone. So I want you to think, on one hand, about populationproblem.org, that is, we have to avoid the apocalypse of too many people. And here we have a wonderful article that was reported in Fox News website, and it goes like this: lack of babies could mean the extinction of the Japanese people. Here's the text of the article. Japanese researchers have now warned of a doomsday scenario if it carries on this way, with the last child to be born there in 3011, very precise, 3011, and the Japanese people potentially disappearing a few generations later. This is wonderful. How many generations will there be after the last person is born? All right. So we have this world of sort of apocalypse on one hand and this kind of nonsense on the other hand, but depopulation is real. Right? Now, Japan is not going to shrink uniformly by 30%. Some regions in Japan are going to shrink by 50% or 60% between now and 2050. You're going to have places with schools disappearing. You're going to have places with hospitals disappearing. You're going to have places in Japan where the roads basically go to towns that are empty. This is a difficult task to deal with. What do you do when you enter this part of the game? How do you deal with that? Well, here is a little factoid about Japan that actually I found in an article by one of the other people who are going to give a talk in this series. Japan now has rental relatives. You see, if you're going to get married and you're going to have a big party, but you don't have very many relatives, that doesn't look too good, and so you rent them. So I thought, what a wonderful occupation. I thought, what would it be like to be a rental relative whose job it is to go to parties every day? You have to go, and you have to eat the good food, and you have to be in a good mood, and you have to congratulate the bride and groom. I mean, I think this must be one of the world's best jobs, to be a rental relative in Japan. But it's what happens when populations shrink. You have these kind of adaptations. Now, of course, China's population will pretty soon be shrinking, and it's expected to shrink overall by 7% between 2025 and 2050. This is a footnote, but that doesn't mean also that China is going to shrink uniformly, and you're going to have the same sorts of things going on in parts of China as you have in terms of Japan. Now, how does the world cope with these population explosions and population implosions? And the answer is they spend money on both of them. So the world is now spending money, but not very much money, on family planning programs in developed countries, and it's spending much more money to get more people born in the developed countries, Japan, Russia. So in Germany, for example, you could get 20,000 euros if you're in the right categories. For the first year a baby's born, that's quite a sum of money, and money every year for 18 years of a baby's life. And Singapore is sort of a little more cuddly. They have the baby bonus scheme. Their website says, "Children bring joy to the family. The baby bonus scheme supports parents' decisions to have more children." Okay? So the world is paying people to have more children in some places, and it's paying people to have fewer children in other places. Is this the right way to play the game? Is this sensible? Is this the way you would play it? So this B comes back in now another context. We live in a very unbalanced demographic world. If people tell you that there are population explosions, that's correct. And if people tell you there are population implosions, that's correct. And we have to somehow manage our way through this complicated set of conditions that we're living in. Now I want to go back and talk about aging more on a country level. Now, there are lots of financial problems with aging. There are pension problems, there are healthcare problems, there's problems having to do with the demand for physical assistance and for people who are disabled. Now, most pension problems are dealt with actually pretty easily. In Canada, the normal pension age is now going up to 67 from 65, if there's one way to deal with the problem. And once those kind of adjustments are made, then pension problems having to do with aging are not very great. There are other issues having to do with medical care, but if you do the arithmetic, very little of that is actually due to aging, and most of that is due to increases in medical costs of pharmaceuticals, cost of various procedures, that sort of thing. But I just want to talk for a moment about this issue of the demand for physical assistance. And here's an article that Sergei Sherbov and I wrote. Demographers deal with things sometimes called old age dependency ratios. And that basically looks at the number of people who are somehow considered old compared to the number of people who can support them. So the standard old age dependency ratio is the number of people age 65 and above divided by the number of people 20 to 64. We think that the world should be thought about somewhat differently, I told you. And in the last three columns, we defined a new ratio, which has basically the number of people who are disabled in the numerator compared to the number of adults who are not disabled. It is basically the number of people who need care divided by the number of people who can give care. And if you're interested sort of in what Canada looks like, it's not here on the graph, but it will be very much like the United States. And if you look at the United States, the standard way of looking at it, which is the old age dependency ratio, goes up from 0.21 in 2005-10 to 0.38, 2045-50, not quite doubling. If you look in terms of disabilities, that number goes up from 0.09 to 0.10, very little. Right? So when you take into account that over time, older people are becoming less and less disabled, aging does not look as like a frightening thing that we have to deal with. How about deforestation and biodiversity loss? This is a serious issue. And these are two baby orangutans living in Indonesia. Now, Indonesia is famous for a number of things, one of which is its rate of deforestation. Rate of deforestation in Indonesia is the highest in the world, or one of the highest in the world. And this has to do in part with the expansion of palm oil plantations. And palm oil plantations turn out to be best right in the environment where these cuddly little orangutans live. And we need to have some way in the world to deal with things like deforestation and biodiversity loss. So what is the view that people have about deforestation? Well, the standard view is, well, the world's rural populations, especially in the countries with high deforestation, are growing and putting pressure on resources. They're moving into these lands which used to be reserved for the orangutans and other creatures. And it's this population pressure in the local environment which is causing the deforestation. Turns out that view is wrong. Now here we have the rural populations of Brazil and Indonesia. Brazil is famous because the amount of deforestation in the Amazon basin is enormous. It's sort of the champ in terms of the number of hectares that are destroyed every year. And Indonesia is the champ in the rate of deforestation. So look at the bottom graph for a moment, and you see that the rural population of Brazil, which is famous for the amount of deforestation in the Amazon basin, has actually been declining from 1975 onwards. It's not the exploding rural population of Brazil that brought people into the Amazon basin. And what about Indonesia? Well, all this expansion of these palm oil plantations has gone on in the time in which the rural population is going down. Well, what's happening? Countries want to export more. They build roads into these forests. They exploit resources that haven't been exploited before, and they sell it some other places, palm oil to the rich countries of the world. So if you thought that it is the expanding populations of Brazil and Indonesia that were the things that were causing deforestation and biodiversity loss there, that's not right. You cannot solve this problem of biodiversity loss by going to Brazil and Indonesia and say you should have fewer people. Now, I already showed you that Brazil and Indonesia already have below replacement fertility. So you're going to go to the countries with below replacement fertility and tell them they should even have fewer children. But it's not the number of people in the rural areas which is doing the damage. It's more likely you and me who's doing the damage by buying these products that are produced in these areas. Well, I just want to say one word about local air pollution. So this is Beijing, you know, January 13th of this year. Beijing had a crisis in terms of a pollutant called PM 2.5, which is a very, very dangerous pollutant. It's very small particles. You breathe it in, it goes into your lungs, and then through your lungs into your blood. And essentially, you have dusty blood. It goes all over your body, and it kills you. The WHO standard for one-day exposure to PM 2.5 is 25 microns per cubic meter. In Beijing, on January 13th, it was up to 1,000. Now, "16 out of 20 of the world's most polluted cities in the world are in China." Think back now to 1980. You could think back and make this argument, which is China's population is growing very fast. We need to have the world's most draconian family planning program in the world in order to bring down the population so that we won't have cities that are so polluted. Well, we had the most draconian family planning programs in the world, and now we have the most polluted cities in the world. Pollution has to be dealt with differently. Pollution is not a matter of taking people and forcing them to have abortions if they have a second child. That's not the way to cure pollution. That didn't work in China, it doesn't work anywhere. We have many, many serious problems. Some, like climate change, deforestation, are very difficult to deal with, but they're not made any easier to deal with by misdiagnosing them as basically population problems. To solve the world's problems, it's important that we understand them. It's important that we understand what component of them is due to population, what component has to do with policies that are not population policies. Some very important, difficult problems are not population problems, and we have to solve them on the way to the world's population plateau if we're going to be successful. Now, that smartphone that I told you about at the beginning was given to me by our son and his wife, and they have a wonderful 16-month-old baby called Ryan. Ryan was born in 2011. And in 2040, when the world's CO2 concentration might get up to 450 ppm, he's only going to be 29 years old. He's going to be 39 when we get to the world's population plateau. And I have two other wonderful grandchildren, Milo and Ruben. And for them, this game is a very serious matter. Demography is not our destiny, but the fact that population growth is slowing and comes to an end provides us with a window of opportunity. It provides us with a goal which says if we can get ourselves to a stable population, a sustainable population, hopefully, by 2050 or so, let's try to make other dimensions of our existence on this planet also sustainable. The window of opportunity says the demography will be permissive. Let's do the other stuff that we need to do in order to live sustainably on our planet. We have this opportunity And the last B is let's not blow it. Thank you very much.